it's Judy Warner. Welcome back to this special edition of the Ecosystem Podcast. Today, I'm going to have an authentic human and technical conversation with SI pioneer, expert, and author Donald Telian. We're going to talk about how we've partnered together to go on the road, putting on an SI Masterclass. It will take place in Boston, Denver, and Santa Clara, and we're really coming up on deadlines here, and we want to tell you about what you'll learn in the class, why we're putting it, and why we think it will have such a major impact on your career. I hope you'll enjoy this conversation. We've put all the links to what we've talked about in the show notes, and you can go to thedoubleecosystem.com and click on the Masterclass tab to sign up today. Now let's jump into our conversation with Donald Telian. Hi, Don. So good to see you again. I'm excited to talk about our exciting Masterclass adventure that we're partnering on.
Yeah, I know. We're back. Let's go.
So you have been teaching me something that I have found profound and sort of mind-blowing, which is that signal integrity, what it is today, is not what it was 30, 40 years ago, and that it's like a whole paradigm shift. So can you tell me and tell our listeners what you mean by that?
Yeah. Thanks for that. And actually, that's what kind of makes the class what it is. So I think this is a great place to start, Judy. 40 years, of course, something had to change. We're going 5,000 times faster. I got this little slide, but it kind of talks about the first era and the things we cared about and the language we used, let's say, for the first 20 years. And then it talks about kind of an in-between time. In fact, if you look at the date line down towards the bottom, there's sort of a no man's land there where we had to there was an identity crisis, really. We had to reinvent ourselves. We had to come up with new types of models. At that point, signal performance is no longer measured on your PCB. Like, it's somewhere else. Where is it? Oh my goodness.
Yeah. Where is it?
Yeah. So like the lines say on the side there, we're writing Moore's law, and ICs have become 1 million times more dense, right? And if you think about PCB technologies, like I started 40 years ago, we were doing 12 mil lines, So I'm being generous there. Like, maybe some people are using 3 mil, but we're at 4. Aside from some material changes, maybe PCBs have been kind of static. So I started saying this in that transition area between 2004, 2007, that signal integrity is moving inside the chip, okay? And indeed, this is where we measure performance now. You can't put an oscilloscope probe there. Sorry. So how do you live in that world?
So what is the risk to engineers who may be looking at the wrong thing or focusing at a really granular level at the transmission line or copper roughness or whatever it is, the stack up, all these things, are they still important? And what are the risks to engineers if they're really not looking in the right places? And,
Yeah.
And then what's to gain if they sort of modernize their paradigm of that?
Yeah, I got you. So let me be clear, because I'm not saying don't look at those things, right? Okay, copper roughness, that's a big deal, right? Okay, so we have to think about those things, but so much of that now has been automated into our tools, ingrained into our thinking, right? So I don't necessarily have to, in 1991, I talked myself hoarse trying to convince people that PCB traces are transmission lines, okay? I don't have to do that anymore. Everybody knows that that's true now, right? And return currents. Oh, that's all got to happen, right? But people get that now, okay? So if you're thinking in the old school, great, okay? But you're looking at half the problem, and you're looking through somewhat of an old lens, okay? And so you're not only missing the secret sauce or what is making this work, but you're missing huge performance opportunity, okay? So can I go to the next picture? Because I think that's going to explain that.
Okay. Yeah. So yeah, I want to see what the other half of the issue is.
This picture talks about the two things. So we might think of this as the two halves, and in a second, I'm going to turn this
Okay.
into day 1, day 2 of the class. Okay. But
Okay.
hold that thought for now. All right.
Okay.
So everybody look at the signals for a second. And, if this really fascinates you, by the way, there's a YouTube of me talking with Robert Feranec about this thing for an hour and a half.
Okay. And I'll put that, since you mentioned it, I'll put it in the show notes too. So.
Yeah, thanks. Yeah. So there you have a nice, clean looking connection. Transmitter to receiver, we get that. We connected it, right? But like in a Gen 5-ish world with 36 dB of loss, okay? I'm launching a 1 volt signal. I get like 10 millivolts down at the other end, okay? So that's the blue signal. The blue signal is what you get at the input to your receiver, okay? That thing, I show a little eye diagram there. That thing is, as far as everyone's concerned, that's actually not really a signal. It's ridiculous. But there is information encoded in there. And so if your viewers zoom in on that thing, they'll see the slightest change in slope. The slightest wiggle of signal is actually a bit change, okay? That is figured out by the red signal. So we'll talk about the red signal in a second. But day 1 of the class, like, you have to learn the things that are going to get your blue signal from transmitter to receiver with 10 millivolt accuracy. Like, think about that. So I can't tolerate certain reflections. I can't tolerate noise, right? So it's not like the PCB side is just, oh, forget that, don't worry about it. No, that's half the problem. So that's day 1 in the class, right? Okay. You see those letters EQ. That stands for equalization, okay? This was the invader from outer space that showed up in signal integrity, okay? Around 2000, whatever, early 2000s, right? And this thing, though, is what's making everything work, right? Because that blue signal, while the IC can perceive it and act on it, the success of extracting that blue signal from the blue to the red rests entirely upon the equalization, which is what's taking advantage of Moore's law, okay? Equalization in our next speed jump, that's going to go 5 times more complicated, right? And the PCB's actually going to get, we might even say, simpler. Like, the loss budgets are not going up, they're going down. It's amazing what's happening, okay? So these are the ditches I've fallen into and the stuff I've wrestled with for 20 years, right? I have discovered that whether or not that equalization is set right and configured right, that is the number one reason that serial links fail. It is completely the reason why they work, but it's the number one reason why they fail. So you read my articles in Signal Integrity Journal. Like I've gone in and fixed crosstalk issues, Judy, by programming the equalization, by setting software registers. That's ridiculous.
Wild.
So this is where I've focused my attention. My customers, they're winning because they're looking at the multidimensional, both sides, the red and the blue of the problem, right? And we're coding in for success. Now, the ones who find me because serial links, this is what I do. They find me because they're not working. They're not working, and I, and so I go in and I look at what's going on. So number one problem is the equalization is not in the right space. It's not set right. So we adjust that, and they're like, wait, I didn't have to spin any hardware? That's ridiculous, right? So they do spin their hardware and they make changes, but they can fix the problem in the lab and see that Telian's actually not nuts. Like they can fix the problem in the lab and wow,
and
look at my bit error rate. It's working now. This is bad. So that's the number one problem. Now, when I get their boards, I also see, here's some discontinuities. That's the number 2 problem. So this is where the class goes. We go from where the problems are, and then we go really fast into how to fix them. So there's a day on the blue waveform. Let's get the blue waveform to the receiver with integrity. But then day 2 is the deep dive. And a lot of that is the stuff that isn't quite in the book yet. I mean, I'm working on it, but if your viewers have written a book, they find there's a little delay, right? So day 2 of the class, attendees are going to be sitting there in software, and they're going to, believe it or not, double E's from around the planet are going to be sitting there. And oh my goodness, I just opened my eye by changing my transmitter equalization, my receiver equalization. I mean, I find that kind of exciting, honestly. It's
exciting, and yeah, and it's why you've won me over as much. I can't go into the deep equalization world, obviously, as you can, but just the concept makes sense to me from everything I've seen, in that everybody's typically focusing on board effects. And this makes a lot of sense to me, because I know they put in a lot of that SI capability inside the chip. So, and again, It's like, why are we suffering unnecessarily? So let's talk about how you and I have had discussions and how we come up with creating a learning path that sticks. That people can have those aha moments, and their career will be absolutely transformed.
I live in the mountains. I got a good friend, and he guides people up Mount Rainier. Okay? Right? So if you want to get to the top of Mount Rainier, what are you going to do? You go to Google, print out a little path, or you're going to go with someone who's been to the top. Like, you're going to be ice climbing. It's going to be ridiculous. Like, how are you going to do this? Are you going to get that out of the digital world, or are you going to leverage somebody who knows? Okay. So I think, if I rewind the clock, this is how I've succeeded. Okay. Am I just old school, or is this the way humanity's worked for thousands of years? You tell. This is a great topic. Okay. But you tell me what you're thinking, Judy.
Yeah. You and I have had this jam over for thousands of years. The way that people learned was through apprenticeships, mentorships, by somebody teaching somebody, then letting them do it, watching them, giving them feedback. And that's why we call it a masterclass, right? And music, as you know, since you're a drummer, you watch a master play a piece, and there's an imitation factor, and then the master gives you feedback. This way, not that way. And we have been doing apprenticeship for generations. And in this digital world, we've forgotten. And we've also learned in community, in person, and we've lost so much of that. And the reason I'm so passionate about this is because the experience that I had when we created Altium Live, and, people like to put engineers in this stereotypical, they're not social. It's a lie. When they're around people talking about engineering, it impacts them. I remember one kid saying, he just graduated with a master's degree from UCLA. And he said, I just learned more in an hour from Eric Bogatin than I learned in my last 10 weeks of school. So to me, it was the in-person piece. And then he could go talk to Eric, and he could say, I have this one problem. Eric would go, da-da-da. Well, the same thing to me is available here, rather than, and there's so much talk out there about theory. And Eric Bogatin actually reviewed your book and said, this is all the stuff that's not in the textbooks, right? And I think people just want to know what the answer is. They don't have the time or energy to go into theory. and I had an old friend who was thinking about this yesterday, friend John Toussaint has passed now, but he used to say, and this was relative to bear boards, he always says that physics trumps theory.
I mean, I am an engineer, right? I dig theory. We're not ditching theory, but when do I need it? Why do I need it? Where do I apply it? But this is what experience gets you. When I'm at dance class with my wife, the teacher looks at my feet, the slightest little wrong turn of my left foot, and she says, "Oh, you shouldn't turn your left foot like that." And I go,
right.
"Wait, I didn't do anything with my left foot. What are you talking about?" But sure enough,
right.
We try again, and then I fix my left foot, and then everything works.
It's an adventure, and let's talk about that too. I'm a pretty social person. Like I said, I threw these global events, and it taught me something really profound about engineers, the way they learn, that we included fun, that we included a beer, that we included a ton of good teaching. And when we put engineers in that environment, it changed their careers. How can we encourage to get these guys and gals to join us on the adventure? Because you and I are personally putting in our money, our time. We're both self-employed. Like, this isn't like, oh, you've got this big expense account from this company with a big marketing budget. Like, we're going all in because we believe it, right? Crazy or not. And so what do you have to say about that? Because I know you said get out of the design cave. So talk about design caves and why leave them.
We've talked about the value of human interaction, but the value proposition here is unbelievable. I'm not going to get into what an hour of my time costs when your board's not working. Like, I don't want to talk to you then. I want to talk to you on the other side. Right. And so I mean, there's got to be stuff that's still confusing back at your desk, but that's where we installed these office hours, Judy. That's where we installed, because the poor, cerebral matter can only digest so much at once, right? So even if a inkling of a concept got in there, and then you're back at the desk 3.5 weeks later, and you're like, oh, I heard this about that, right? You dial into office hours, and then we get to connect the dots, right? Because this is about everyone winning.
And there's no reason why it can't be that way. And I think also, as just American business culture, we've gotten to this belief about zero-sum games, and I don't buy it, and I don't think you do either. I think there's a way for everybody to win, and I think that's what we aspire to. So let's talk about that multidimensional learning. So you mentioned the office hours. Because we do believe that in-person is important, we're doing that. And then because we think people getting their hands on it, your whole day 2 is all about hands-on, where there can be Q&A, and we're getting the MathWorks people involved to help, and then there's the office hours, and then you're giving them your fancy book that's, $85 or whatever it is. So you're giving them that. So what else? I think the office hours honestly can't be overstated, because having access to you, whatever, once or twice a month, whatever you choose to make yourself available, God, I would kill for that, right? And again, consultants make pretty good money hourly because they're firefighting, and saving a project or a deadline or a schedule or a time to market. Yeah. So that people get this sort of access to you, I think, is worth it alone. But that's my humble opinion.
Well, thanks for that. I mean, it's a funny thing. I know there's going to be aha moments in the class, in the labs, in the office hours, but part of the mystery is, we're also, it may connect, after we finish our dinner together, right? Like, we're going to do a 5K run. Like, you might be out there in your running shoes next to me, like, just being nice and not beating me to death. and we're just talking
Right.
about stuff. I mean, I
Right.
do this. I very memorable conversations with engineers out on the running path.
This is an invitation. This is an invitation to adventure, to learning, to success. I have working with engineers for 30 years. The ones that become the most successful and valuable, both at work and at home, are the ones that step outside of their comfort zone. And I think of there's a ex-Navy SEAL, Jocko Willink, and he wrote a best-selling book called Extreme Ownership. And
Uh-huh.
I've gotten to speak at universities, and what I've been telling these kids is like, this is your career. It doesn't matter where your paycheck comes from. This is your life. So don't dial it in like extreme ownership. Don't be passive about it. Invest in it, because we spend most of our lives working. And, I think the more you invest in yourself and invest in others, the richer your life is. So I'm always pounding, particularly on young engineers, if they let me, mom factor, Telian, mom alert, mom warning, is I say, take ownership of your career. And like you were self-employed, this is your actual life. Like, it affects all areas of your life. So
Yeah.
what do you have to
Yeah.
say about that? I know you have similar philosophy. That's the way I think of it, of extreme ownership of your life, but certainly your career.
Gosh, I don't know if I would dare to put a cherry on top of that. That's so well said, and I don't wish, but I mean, it's not as simple as just lots of hours, I mean, it may get pitched to you that way from management, but it's more like a mindset of things are possible.
Yes.
Like, I can do this, right?
Yes.
We've already said, I doubled data rate a dozen times, right? I've been up that mountain. Like, I'm like, yeah, that's what we do. Like, I'm not, everyone's like, oh no, but
right. The
that's
sky is falling.
That's what this is, So, yeah, some things are more caught than taught. Like, I raised 8 kids, like I wasn't there staying until midnight. I had stuff to do, So it's,
right.
Again,
but you can work smarter. You can work smarter, not harder. And if you don't have to spin a board, if you can spin a board 1 time instead of 3 times, that's better.
Yes.
Right?
Yes. So for technical,
and then you get accolades of work. Then you can leave work earlier. Like, it's right. I mean, it's about being smart. It's not about living in the grind and neglecting your family or your life or your exercise. You and I are not about that.
So I'm going to go technical on you again, because some engineers watching, they're like, this is so touchy-feely. Okay, but back to my red and blue waveforms. Sorry, Judy, this is what we do.
No,
back
it's good.
To my red and blue. This is the thing I didn't say, right? That I see is working smarter, right? That I see,
yes,
is taking this blue mass and working smarter. Like, it's been put into transistors, right? So the thing I didn't say is that eye diagram that tells you that the signal has integrity, right, is buried deep inside the integrated circuit, right? And so specifications for many generations have said, this is how we're going to measure signal integrity. We're going to measure it thousands of transistors inside the IC, right?
Yep. Yeah, that thing you can't probe, touch, see, or understand, right?
No, I'm not comfortable. I want my PCB, give it back to me, right? But like it or not, sports fans, here it is, and so we can do this thing. We can understand that, right? I mean, some ICs, they'll let you through other registers dump the eye plot back out at you, right? That's how geeky it all is now, right? Okay, but you can know what's going to happen before you ever build anything. And that's the secret
It's
sauce.
empowering. Invest in a way that actually gives you back quality of life and gives you more ownership and a sense of control and mastery and competence, right? Rather than feeling like, well, I hope this works, or leaving, people didn't learn this in university. And even if they did, in 3 years, it doesn't apply anymore because the data rates keep going up. I think engineers are underappreciated and overworked and are giving impossible workloads and things to do. So I'm all about delivering the tools, experience, and things that put some of that, gets rid of any kind of sense of imposter syndrome or fear and moves us towards competence and life and goodness, right? So it is a little touchy-feely, but so it
well
applies.
Said. Absolutely. So we're putting like we are limited by time and space a bit, okay, but we're putting the class strategically around the globe near big airports, right? So this is us meeting your viewers halfway, maybe more than halfway, right? You know, we want it to be a short flight for you if you're not in one of these tech hubs, right? We want it to be a short flight for you, don't need to rent a car, Uber over the hotel, whatever, and let's hang out, let's do this thing.
Our next class is going to be in Boston, and it's like 2 or 3 weeks away. So we encourage you to come join us there. We've got dinner at a microbrewery. Don's all fired up. He's been working tirelessly on preparing these materials that includes the principles from the books, but gives all those nuances. Plus, he's there. So I think we put together something really special, and we hope that you'll join us in Boston. Following that, we'll be in Denver, and following that, we'll be in Santa Clara. So this is our U.S. tour. And providing we're successful here, we're going to take the show on the road and go to Europe and bring it wherever engineers are. So thank you for your time, Don. Thank you for showing us the blue and the red line and explaining what you're going to teach in this class.
Yeah, absolutely. Thanks for that, Judy. It just makes sense. Like it seems like the moment is here right now, right at this, juxtaposition of technology change and it's time to not blame everything on COVID, right? Like we're people.
Right. Right. I mean, I think it'd be good. I know it'll be good for me. We need to get our feet on the grass. So
there it is.
Don, thank you again. And for our listeners, come on out. Let's get our feet on the grass. Let's go for a 5K run. Let's have a beer. Let's get in some office hours with Don and do better work and make the world better, make our work better. And I hope you've enjoyed this conversation. And I will put all the links for you in your show notes. I hope this has been helpful in understanding what we're putting together. And we hope that we will see you outside of your design cave. We'll see you next week on the podcast. Until then, remember to always stay connected to the ecosystem.